Alright, so guys, for 7.1.2, it's really just a continuation. It's really just a continuation of the previous lesson, 7.1.1. So a figure is dilated if the pre-image can be mapped to an image using the scale factor through a center point, usually the origin. You've been determining if figures have been dilated, but how do you create a dilation? So basically, we're talking about giving you the scale factor this time and you actually creating the image from the pre-image. The notation is capital D with lowercase k on x, y means k times x and k times y. Basically what it means is you're going to multiply the scale factor times the x value and the y value in the point. Okay, we saw yesterday in 7.1.1 that you can have a vertical stretch or a horizontal stretch where the shape, those rectangle problems, where it's only affecting horizontal or vertical, which is not an example of a dilation. It is a stretch, but it's not a dilation. Dilation has to affect both vertical and horizontal equally. All right, so multiply each coordinate of the figure by the scale factor when the center is at 0, 0. So here's just your example, right? K on CD is C prime D prime. So you have D here, you have D here, and then D prime is out here where you multiply both by K and X and Y by K. So, all right, so moving on from that, the lengths of the sides can also be multiplied by the scale factor. We'll see that in an example here in just a second. If you know the lengths of the pre-image figure and the scale factor, you can calculate the length of the image by multiplying the pre-image length by the scale factor. It's an enlargement if k is greater than 1, reduction if it's between 0 and 1, and a congruency transformation, which basically means it's the same, it stays the same if k is 1. All right, some errors, misconceptions, and example 1. If AB has a length of 3 units and is dilated by a scale factor of 2.25, what is the length of A prime, B prime? So what you would all we gotta do there is 3 times 2.25. Okay, and if you do 3 times 2.25, you end up with 6.75. Okay, so 6.75 is your new length, is the length of A prime, B prime. Okay, that's it. Like I do. If they gave you units, then you would label it as however many units. But that's your answer to that one. Okay, so we'll go ahead and do the next example. Try and get them all done in one video because this is pretty easy. All right, this one's kind of already been done for you. A triangle has vertices G, H, J. If the triangle is dilated by a scale factor of 0.5 through the center 0, 0, what are the image vertices? So the solid line that you have drawn here in the picture is the original points, and then when you do 0.5, basically 0, 4 becomes 0, 2, negative 6, 2 becomes negative 3, 1, and 2, negative 3 becomes 1, negative 1.5. All right, so that, and also that would be, of course, a reduction because the 0.5 is less than 1, but still greater than 0. Okay, so nothing to show you there. It's already done. The dotted line shows what happens there. All right, this last one. Same kind of deal. What are the side lengths of D prime, E prime, F prime with a scale factor of 2.5 given the pre-image? So basically you take each length, you take 8.6, 1, and 9.2, and we're going to multiply them by the scale factor. Okay. The picture's already drawn, and the center is here, which is why you notice that the dotted line shape is to the right a little bit of the originals because we're moving away from that center. So we know the lengths. We've already got those labeled. So F prime, D prime, that's 8.6. So what I want to do there is 8.6 times what? What was my scale factor? It was 2.5. So 2.5, that's 21.5. So D prime, F prime is 21.5. And then 1, that's really straightforward. D prime, E prime is going to be 2.5, and E prime, F prime would be 9.2 times the scale factor, which is 23. And that's it. Of course, that would represent an enlargement because we're multiplying something greater than 1. So super easy lesson if you understood what we did yesterday. If you have questions, stop me and ask me. Make sure you get this down because we're going to move on to some harder stuff next week, okay?